Finite Mathematics Chapter 9, Section 4, Binomial Probability. Binomial experiments. A binomial distribution occurs when the same experiment is repeated many times and each repetition is independent of previous ones. In other words, this time when I do the experiment, it's not going to be affected by the results of my previous trials. One outcome is designated a success and any other outcome is considered a failure. That means there's only two possible outcomes. You either succeed or you fail. You get what you want or you don't. For example, if you want to find the probability of rolling 8 twos in 12 rolls of a die, then rolling a 2 would be considered a success and anything else you would roll would be considered a failure. The individual trials are called Bernoulli trials or Bernoulli processes. If the probability of success in a single trial is p, then the probability of failure is 1 minus p. And the resulting distribution of the outcomes of these trials is called a binomial distribution. So binomial experiment has 4 characteristics. It's the same experiment repeated a fixed number of times, so you're only going to do it so many times. There's only 2 possible outcomes, success or failure. The probability of success for each trial is constant. It doesn't change based on which trial you're doing. And the repeated trials are independent. They don't affect each other. If p is the probability of success in a single trial of a binomial experiment, the probability of x successes and n minus x failures in n independent repeated trials of the experiment is. Okay, we have n choose x times p to the x times 1 minus p to the n minus x. Okay, in other words, what this is saying is you've got a fixed probability of success and you know what that is, and that's being symbolized by the letter p. You are going to do this experiment n number of times. You want to get x number of successes. The probability of that happening can be determined by this formula. So we have an example. According to a 2012 study conducted by the Society for Human Resource Management, 81% of U.S. employees reported overall job satisfaction. Suppose a random sample of 6 employees is chosen. Find the probability of the given scenarios. Now, 6 is our set number of trials. Okay, that's our n. The probability of success, 81%, so 0.81. Now let's look at A. Exactly 4 of the 6 employees have overall job satisfaction. In other words, you're doing this 6 times, n is 6. You want 4 successes. That's going to be your x. Pause the recording, use the formula, and then resume to check your answer. And then part B, all 6 have overall job satisfaction. You can go ahead and do that one too. Again, 6 trials, 6 successes. What's the probability? Pause the recording, use the formula, resume to check your answer. Okay, for part A, you just set up the formula. It's 6 choose 4, 6 trials total, 4 successes desired. Your chance of success is 81%, so 0.81 to the 4th, which is what you want to succeed. And then the chance of failure is 1 minus 0.81, or 0.19, and that's going to be to the 2nd. And then multiplying all that out, we get 0.233. For part B, you want x to be 6. That means that you want 0 failures. So 6 choose 6, 0.81 to the 6, 1 minus 0.81 to the 6 minus 6, which will be 0. Remember, anything to the 0 power is 1. You have a 0.282 probability of having all 6 that you've selected have overall job satisfaction. And now suppose a family has 3 children. Find the probability distribution for the number of girls. Okay, pause the recording, give this a try, and resume to check your answer. All right, so we're just doing a little probability distribution chart here. If you have 3 children, you have 4 possibilities. There are no girls, 1 girl, 2 girls, or 3 girls. And you just want to find the probability of each. According to the binomial probability rule, You're just going to put these numbers in. We're assuming that you have an equally likely chance of having a boy or girl, as we always do for this problem. So the chance of having exactly one girl would be 3 choose 1. 1/2 to the first times 1/2 to the second. Multiply that out and you get 3/8. You see them spelled out here in the chart. They have the formula set up and the answer. So 1/8, 3/8, 3/8, and 1/8. Now use the chart you just made to find the expected number of girls in a 3-child family. Pause the recording, give this a try, and resume to check your answer. Now the solution given here is a little more of a common sense solution. If it's E, you're equally likely to have a boy or girl out of 3 children, then half the time you expect to have girls would be 1.5. You can also get this answer by doing the method that we've used for expected value, which is multiplying x by its probability and then adding those together from the chart. Either way, you get 1.5. And when an experiment meets the 4 conditions of a binomial experiment with n fixed trials and constant probability of success, the expected value is n times p. So if you meet all 4 conditions, you have a set number of trials, you know the probability of success, multiply the number of trials by the probability of success, and that gives you the expected value. And again, we saw that with the last problem. You have a probability, 0.5 of having a girl, 3 trials, 3 times 0.5 gives you 1.5. According to the real estate data provider CoreLogic, as presented in the Los Angeles Times on March 13, 2013, approximately 21.5% of U.S. households with a mortgage owed more on their mortgage than the value of the home. That's commonly known as being underwater. It's also known as being upside down. If we select 15 U.S. households with a mortgage at random, find the following probabilities. Find the probability that exactly 5 of the households had a mortgage that was underwater. All right, pause the recording, give it a try, and resume to check your answer. So we are repeating this experiment 15 times, and we want to know the chances of having 5 that have a mortgage that's underwater. So underwater mortgage is considered a success because that's what we're interested in finding out about. Putting it in the formula, we have 15 choose 5 times 0.215, which is our probability of success to the 5th power, times 0.785, the probability of failure to the 10th power, and we get 0.123. Now try these parts. Find the probability that at most 3 households had a mortgage underwater, and then finally find the expected number of households with mortgages that are underwater. Pause the recording, give these a try, and resume to check your answer. Okay, at most 3 means 0, 1, 2, or 3, and really the only way to do this is just to find them and add them up. So, putting each of these into our formula, we get 0.026 for 0, 0.109 for 1, 0.209 for 2, 0.248 for 3, add them together, and you find that the probability of having at most 3 would be 0.592. Part C should be pretty easy. I'm just going to use the formula we just had. If you didn't do that earlier, go ahead and do that now. We're doing 15 trials. The probability of success is 0.215. So 15 times 0.215 gives you 3.225, which is the expected value. According to the Small Business Administration, 1/3, or about 0.333, of new businesses fail within 2 years. If 10 new businesses are selected at random, what's the probability that at least 1 will fail within 2 years? Okay, again, there's that word at least. Remember, that means 1 or 2 or 3 or 4. Also remember, there's an easy way to do this and kind of work around having to do all that. Pause the recording, give it a try, and resume to check your answer. Okay, So we're treating it as a binomial experiment. It's success or fail. We have a set number of trials, which is 10. We have a set success rate, 0.33. What we're going to do is we're going to find the opposite of at least one. The opposite of at least one is none. If you don't have at least one that failed, then you have none that failed. And then we'll subtract that probability from 1. So the probability that there were no failures would be 10 choose 0, 0.333 to the 0 times 0.667 to the 10th, and that gives us 0.017. Now what we're going to do is we're going to subtract that from 1. So 1 minus 0.017 gives us 0.983. So you have a 98% chance that if you pick 10 new businesses, at least one will have failed within 2 years. If each member of a 9-person jury acts independently of the other, okay, independent, that's important, and makes the correct determination of guilt or innocence with a probability of 0.65, there's our success, find the probability that the majority of the jurors will reach a correct verdict. Okay, 9 people on the jury, they're independent. Probability of success of choosing correctly is 0.65. Pause the recording, give this a try, and resume to check your answer. Okay, since they're acting independently, we can treat the problem as binomial. The majority will reach the correct verdict. Now, majority, you've got 9 people, so that means you need to have 5, 6, 7, 8, or 9 come to the correct verdict. And there's really no way to do this. Well, there are 2 ways to do it. You could do 0 through 4, 0, 1, 2, 3, 4, and then subtract it from 1. But either way, you're going to end up doing about the same work, so you might as well just do at least 5. So find the probabilities for each of those for 5, 6, 7, 8, and 9, as you see here. Add those together, and you get 0.8283. Okay, the rest of this is extra practice, so pause the recording, give these problems a try, resume the recording to see how you did, and continue this way through the rest of the video.